Okay, now we're gonna solve the following inequality. So this is our first in our series. So the first step is to read the question. We want to solve for what? We want to solve for the values of x. It's not one single value. Here we are looking for intervals. So we want to find the values of x that would make this inequality true. Okay? And one key idea is to find the values for the square root, where the square root is defined, because we can't just square everything and go. We're gonna make mistakes. So we need to find where this one is defined and proceed from there. So the condition here is that everything inside the square root has to be positive. So that means that we need to find x minus 1 times x minus 3 strictly bigger than 0. The best way to do that is to make a small table. Okay, so it's a small table here where we have on the upper row we have all the values of that x can take with their roots, their zeros. So like this inequality, when we have 1, it's 0. When we have x equals 1 or 3, it's 0. And 0 bigger than 0, it's just inequality, the equation. Okay, so that would make this one 0. And after that, we check the sign of x minus 1 in one row, the sign of x minus 3 in one row, and we make the product of these two rows to make sure that we get the sign of x minus 1 times x minus 3. So here, when x is 1, x minus 1 is 0. If x is bigger than 1, x minus 1 is positive. So we put plus sign here. If it's less than 1, it's negative. The same thing for x minus 3. When x is 3, it's 0. When x is bigger than 3, it's positive. When x is less than 3, it's negative. To get the product here, the sign of this product, we just multiply. So here, this one means that x is bigger than 3 for both cases. That means it's positive, and therefore the product is positive. Here, x is between 1 and 3. And 1 is positive, 1 is negative. When we do the product, we get negative. Here, when x is less than 1, both of them are negative, and their product is positive. We are interested in the values where this quantity is positive. That means we are in this interval. Minus, you read it from here. So minus infinity to 1, union 3 plus infinity. So our interval is minus infinity 1, union 3 plus infinity. Okay? So any value that would make this through has to be in this interval. In this interval, we will see more. Now we can square both sides, assuming that x is in this interval. So squaring both sides, we get x minus 1 times x minus 3 bigger than x minus 3 squared. Okay? We will take the x minus 3 to the right, to the left side. We get x minus 1 times x minus 3 minus x minus 3 squared bigger than 0. Now we can factor by x minus 3. X minus 3 times x minus 1 minus x minus 3 bigger than 0. So we keep working this way, and now we simplify this one. The x minus 1 minus x plus 3, it's minus 1 plus 3, which is 2. So we get here. Okay, this means that 2 is bigger than 0. We can multiply both sides by 2 to get x minus 3 bigger than 0. Okay? What does this one mean? It means that x is bigger than 3. So we intersect this set of solutions. So x has to be bigger than 3 to have solutions, to have this inequality true. So in this case, the set of solutions is x bigger than 3 or 3 plus infinity. So this is where this one could be defined, but this is where the solutions are. So x has to be bigger than 3 to have this inequality true. Okay, so the solution is x is bigger than 3, or x belongs to this 3 plus infinity interval. And I think that's it. So we found the solution.